And then these fossils were found and published in 2004 of what seemed to be a dwarf species of human. Clearly, modern humans today have Neanderthal DNA in their genomes. We can look forward to a very rich story still to come. More complexity, but also probably sorting out some of these questions that I've raised that are still doubtful.
Chris, it's great to have you on History Hit today.
It's a pleasure to be with you.
Now, on the ancients, on History Hit, we've covered some huge topics in the past, but there aren't many topics that get bigger than this one, is it? The origins of modern humans, the origins of our species.
It is, yes. I mean, it's a huge question. It's one where we've got a lot of new evidence coming in the last few years.
Well, you've got a few of these replicas out for us today, which we will no doubt talk about in due course. We are at the Natural History Museum today. And Chris, I mean, first of all, the past era for research into looking at early humans and early modern humans, early hominins more generally, it's been a really exciting era for discoveries, hasn't it?
Yes, it has. So we've had obviously wonderful new discoveries of actual fossils. We've had better dating of some of the fossils that already existed. And of course, really excitingly, at least for the later part of the record, we've got DNA added to the story for people like the Neanderthals and these people we discovered from DNA data, the Denisovans living over in East Asia.
Well, you mentioned Neanderthals, you mentioned Denisovans, we will definitely talk about those. But I mean, first of all, regarding fossils and looking at fossils, what other things, what qualities, what features of a fossil are you looking at when you're trying to decide whether this fossil of an early hominin is an early modern human?
Well, yes, so if we haven't got the DNA, we're left with what will fossilise, and that's obviously the bones and the teeth. So I've got here a replica of a modern human, recent human skull.
Yep.
And you can see some of the features that typify our species and things we can look for in the fossil record. So we've got a high and rounded brain case, and it's expanded up here at the back.
Yes.
We've got a small or non-existent brow ridge. We've got a small face that's tucked under the brain case, relatively small teeth. If we had the lower jaw, there'd be a nice chin on it, and here's an example of that on another fossil. We've got relatively large mastoid processes, even down to our ear bones. So we know from CT data, we can look at the inner ear bones of fossils, and we can see that even down at that level, we're distinct from people like the Neanderthals. And in the skeleton, if we have the skeleton of this individual, our skeleton is lightly built, so we're not highly muscled compared with some of these earlier humans. We've got a relatively narrow rib cage, we've got a relatively narrow pelvis, our joint surfaces are smaller. So even in the skeleton, we've got a whole suite of differences, and these are the things that we look for in fossils to mark the evolution of Homo sapiens.
And the evolution of Homo sapiens, but of course Homo sapiens is just one of the Homo species, isn't it? So if we delve into the background now in regards to the origins of modern humans, because what do we know going really far back about the earliest hominins that we know of?
Well, geneticists estimate we had a common ancestor with our closest living relatives, the chimpanzees, maybe around 7 million years ago. And for the first 5 million years of that period or so, human evolution took place only in Africa, as far as we know. And then in the last 2 million years, early humans started to spread from Africa to places like Asia and Europe. So we start to see fossils in those areas, and of course evolution is still going on within Africa. And we start to see a diversification. So for the earliest stages of human evolution, we've got fossils in Africa that are close to 7 million years old. And some people think that these are actually on the human line. Other people are not so sure, because of course when you go back to that common ancestor with chimpanzees, it's not going to look very much like us, because we've had 7 million years of evolution, and it probably won't look much like a chimpanzee either, because the chimpanzees have had 7 million years of evolution from that common ancestor.
I mean, does it seem important to stress, therefore, that by the time we get to the origins of Homo sapiens, the emergence of modern humans, does there seem to be this rich diversity of different Homo species present in the world at that time?
That's right, yes. So what we see now from the fossil evidence is a great diversity. At every level where we've got good evidence, we see there are a number of species coexisting. It's as though nature's experimenting in how to be human with all these different lineages. And so even 70,000 years ago, which is like yesterday geologically speaking, There were at least 5 kinds of humans around on the Earth. So we were evolving in Africa and starting to emerge from there. The Neanderthals, we've got an example of a replica Neanderthal here, they were evolving in Europe and Asia. Over in East Asia we had these Denisovans, who we know about mostly from their DNA. And we also had on the islands of Southeast Asia 2 strange dwarf species, one of them nicknamed the hobbit, Homo floresiensis, and one in the Philippines that we've only learnt about in the last few years called Homo luzonensis. So that's at least 5 kinds of humans 70,000 years ago. Now there's only 1. So all those other forms disappeared. As we go back in time, there's even more things like Homo heidelbergensis and Homo naledi and so on. So it's a much more complicated story than we used to think.
Well, Chris, and there we go. There's the story of the prehistoric Bilbo Baggins, isn't it? At the same time.
That's right. Yeah, we can cover that.
Okay, Chris. Let's therefore go on to some of these big questions. The first big question: when and where do Homo sapiens originate?
Well, the geneticists estimate we had a common ancestor with the Neanderthals and the Denisovans maybe 600,000 years ago. And I don't think we know what that common ancestor looked like. I used to think it was this species, Homo heidelbergensis, sometimes also called Homo rhodesiensis. So this is a replica of a fossil that was found in what's now Zambia, and it was found in 1921. It was the first important ancient human fossil ever found in Africa. And it's been assigned...
Just to describe that skull which you're holding now, Chris, I mean, looking at it at first glance as a Joe Bloggs, it doesn't look that dissimilar from the skull of a modern human. I mean, its eyes look bigger as well, but what are other key features of it?
Yeah, so we can put them side by side, and you can see there that, you know, the brain case is much longer and lower. The forehead's much flatter. You've got this, as you say, great big brow ridge over the eyes. The face is bigger and it's pulled forwards more. The teeth are larger. When we look at the back of it, it's got this strong ridge of bone across here, an occipital torus, and strongly angled, so that's a distinction. And when we've got the skeletons of these early humans, we see that they're very strongly built, very robust compared with our skeletons. So different from us, I would certainly say a different species. Sometimes called Homo heidelbergensis after a jawbone that was found in Germany in 1907. Other times, I think I'm switching over to using the name given to this fossil in 1921, which is Homo rhodesiensis, because that was the name given to what's now Zambia, was then northern Rhodesia, so Homo rhodesiensis. So this, I used to think, was the common ancestor of us and Neanderthals. Now I think it's not, because it's got some derived features that take it away from what we think the common ancestor was like, especially in the face. And also, we've directly dated this fossil, and it's only about 300,000 years old. So it's too young to be the common ancestor of us and Neanderthals. And there are other fossils which certainly are closer to that position. There's a species we know from Spain called Homo antecessor, pioneer man. Now that material is 850,000 years old. It may be too old to be the common ancestor, but in the face it actually looks closer to what we would predict the common ancestor of us and the Neanderthals look like.
Even though, as you say, we don't think Homo heidelbergensis, I apologise if I butcher the name of that Homo species now, might not be the common ancestor, is the theory that Homo sapiens emerged from Africa, the out of Africa theory, is still dominant?
Yes, so if we go back to that common ancestor maybe 600,000 years ago, I would say we're not even sure where it lived. So that common ancestor may have lived in Africa, may have lived in Europe even, maybe lived in Western Asia, and then from there these different groups diversified and evolved. But after that time, yes, the evolution of Homo sapiens takes place in Africa, only in Africa as far as we know. Until we get to the last couple of 100,000 years, we start to see sporadic signs of Homo sapiens emerging from Africa, but not surviving, not established long term. And then there's a major dispersal about 60,000 years ago, and that is the dispersal that really makes its mark and gives rise to humans today outside of Africa. So that 60,000 year event is the really important one in terms of modern human diversity outside of Africa, and humans of course stayed behind in Africa. So the out of Africa theory is, you know, I prefer to call it the recent African origin model. I think that is still the dominant one, but whereas 20 years ago, I would have said, yeah, we're recent African origin, pretty well 100%. Now I would say we're mostly out of Africa, because we do know even that story's got a bit more complicated. And why I don't use out of Africa as the sort of short term for it is because actually there were other out of Africas. So this species, Homo erectus, most people think that that evolved in Africa more than 2 million years ago, and it came out of Africa around 2 million years ago. So that's a very early out of Africa event, and there could have been more since then. There were probably some back to Africa events that we have a very poor picture of. And so there were actually a number of out of Africa events. The most recent one, the 60,000 year one, is the one that is the most important in terms of our story. And so recent African origin, I prefer to use that term for this model of an African origin for our species.
Do you therefore think it's likely that Homo sapiens evolve in one or from one particular place, or from many different places?
Yeah, that's a difficult one to answer, of course, when, as I say, we've got evidence lacking from much of Africa, but I've certainly moved away from the position of thinking there was one area that was the most important. I used to think East Africa was the most important because that's where we had fossils like Homo kibish. But now I think, I'm part of a group who have developed an idea of a Pan-African origin for Homo sapiens, that we didn't just evolve in one place. Some people have suggested from mitochondrial DNA that we evolved in southern Africa. Other people point to, the Y chromosome DNA suggesting we came from West Africa. But the reality is that it's a more complex origin. I think what we call Homo sapiens today is a kind of an amalgamation of different lineages in different parts of Africa that at times were evolving separately, at other times when the climates allowed it, they spread and they met and mixed and they exchanged genes and ideas. So we actually get a kind of complex web of interactions in Africa. Some of these populations become extinct when the climate turns against them, others carry on, and so we finally get a merging of these groups in the last 100,000 years to become Homo sapiens as we know it today.
Well, let's now focus therefore on this dispersal from out of Africa. So what do we know about the nature of this dispersal of Homo sapiens out of Africa?
Well, there were a number of dispersals, but the really important one that geneticists identify was about 60,000 years ago. It's known really from a reconstruction working backwards from the DNA today of people outside of Africa. It coalesces to around 60,000 years ago. So it's thought that a small group of Homo sapiens got out of northeast Africa into Western Asia, and from there gradually dispersed to where we find Homo sapiens today outside of Africa. And as I say, it wasn't the first movement of Homo sapiens out of Africa, because we've got fossils of Homo sapiens, for example, in Israel that are maybe 120,000 years old at sites like Shkul and Kafse. But in a sense, it looks like they didn't go further with their dispersal, or if they did, it didn't ultimately give rise to the populations we find today. There's even a fossil from Greece that's over 200,000 years old from a site called Apidima. Just the back of a skull, but the back of that skull looks very like a Homo sapiens, even though it's more than 200,000 years old. That again looks like, you could call it a fouled dispersal, because there are Neanderthals that come back to the site afterwards. So there may have been these early attempts at dispersal by Homo sapiens, but it's the one at 60,000 that is successful. But of course, going out of Africa 60,000 years ago was going to take these Homo sapiens into the territory of these other humans who were already living outside of Africa, the Neanderthals and the Denisovans, and even these other species that were living down in Southeast Asia. So that's where we get the possibility of contact between these different forms of humans who've been largely evolving separately for hundreds of thousands of years.
Okay, let's talk about Neanderthals now. So how do they fit into this story of Homo sapien dispersal from Africa?
Yeah, so 20 years ago, if you'd have interviewed me, I'd have said, well, we and the Neanderthals were closely related. There could have been a bit of interbreeding because we know that modern mammal species that are closely related can interbreed. So jackals and wolves, brown bears and polar bears, many species of baboons in Africa can do a bit of interbreeding. Now, I knew that was there, but I thought, well, 40,000 years ago, this wouldn't have been normal behaviour. These were small populations. They probably didn't meet each other very often. And then we've had 40,000 years since to lose any trace of the interbreeding. So I thought, yes, it could have happened, but it's trivial in the big picture. We're never going to find evidence of it today. But in 2010, work started to appear that showed that clearly modern humans today have Neanderthal DNA in their genomes. So there was interbreeding, and you and I probably have around 2% Neanderthal DNA in our genomes from this interbreeding that happened between about 40 and 60,000 years ago. And that's true for pretty well everyone living outside of Africa today has around that level of Neanderthal DNA in their genomes. So it happened, and the first view was it must have happened when we first came out of Africa in Western Asia. We now know it was happening in Europe, it was happening even across Asia. So there were multiple interbreeding events with the Neanderthals contributing little bits of their DNA eventually to our genomes. To begin with, it would have been a high level. So here we've got a replica of a jawbone from Romania.
Oh, yes.
That's directly dated to about 40,000 years ago. Now that's pretty well, that's the time when the Neanderthals were going extinct physically. Now this jawbone, it's got a nice chin on it, so it looks like a modern human jawbone, but people noted that it had unusual features in the teeth and a little feature here that you often find in Neanderthals.
And what's that here? What's that little feature?
It's a little foramen, just a little bridge across the bone here,
Yep.
which you find in about half of the Neanderthal fossils.
That's right at the back of the mouth.
That's right, back of the jaw, inside the jawbone here. So people were saying, well, it's got some strange features. Maybe it's got mixed features. Well, when its genome was analysed, it was found that it had around 9% of Neanderthal DNA. So that's the highest level known in any Homo sapiens fossil. And that suggests this individual had a Neanderthal ancestor within the previous 4 to 6 generations. So we're very close to that interbreeding with the Neanderthals in this fossil from Romania.
It's so interesting, you know, how in really recent research this has come to light. You know, it must be one of the great, shall we say, discoveries, uncoverings of recent history looking into early humans.
That's right, yeah. It is a very important discovery, and it shows that we are not purely recent African origin. We're more than 90% in our genomes recent African origin, but these extra little bits are added on from Neanderthals, from Denisovans. In Africa too, there are suggestions that there was some interbreeding even in Africa of these other, you know, pre-Homo sapiens or alongside Homo sapiens lineages. Even they in Africa were doing a little bit of interbreeding with Homo sapiens. So it's a more complex story. We're mostly out of Africa, mostly recent African origin. And of course, people are looking at what that DNA is doing. So even there's about 2%, as I say, in us, you know, most people outside of Africa today. And some of that DNA is active. So it seems to be active in our immune systems, for example. And that's interesting because, of course, we, having evolved in Africa, coming out of Africa to live in Europe and Asia, we had no natural immunities to the local diseases and pathogens. The Neanderthals had evolved some of those natural defences. So by interbreeding with them, we got a kind of quick fix to our immune system and picked up some of their natural defences. And that was good news 40 or 50,000 years ago. Now it is also linked with some autoimmune diseases. So this even has medical importance. So it's kind of swings and roundabouts that this interbreeding can give you benefits in terms of picking up lost diversity. It has benefits in picking up, you know, innovations in other lineages that they've evolved. You can pick those up as well. But of course, when your genome integrates these bits of DNA from other lineages, they may or may not fit perfectly, and it may be useful, but it also may have some side effects which aren't so good. So it's a balancing act really, and we now know that many closely related mammal species do hybridise, and they do this, and this helps to increase the diversity and pick up, you know, innovations from other lineages. But of course, it may also have some less good effects in some individuals.
So, Chris, what do we know about the features of these Neanderthals?
Well, yeah. So looking at this, you know, late Neanderthal in evolutionary terms, we can see that it's got a big brain. The brain's as big as ours, even a bit bigger than the modern average. But the brain case is longer and lower. It's kind of, you know, spherical when viewed from behind, almost like a ball. There's this double-arched brow ridge over the eyes, a big face, and particularly the middle of the face pulled forwards with a great big nose. Quite big front teeth. If we had the lower jaw, not much of a chin on it. If we have the skeleton of the Neanderthal, we would see a much shorter and wider, compact body, very powerfully built, very big rib cage, wide pelvis, strong muscle markings, very, you know, a body built to withstand a very demanding lifestyle.
So why should we label this as a different species to Homo sapiens?
Yes, well, not everyone does. There are some people who argue that this is a form of Homo sapiens, and of course we've got all this evidence of interbreeding, and people say, well, how can you call it a different species? But yes, I mean, we know now from genomic data that many closely related species do interbreed, so I think us and the Neanderthals doing it is not that unusual. And when we look at the morphology, the Neanderthals over several 100,000 years evolved their own distinctive features, which I think mark them off. Even in things like their ear bones, tiny little structures, they can be distinguished consistently from Homo sapiens.
Now, we mentioned earlier the prehistoric Bilbo Baggins, so let's focus on this one last species before we start wrapping up. Homo floresiensis. Now, Chris, what do we know about this species and how do they relate to our origin story?
Well, I think it's still a very mysterious species. It's a remarkable find. So this was published in 2004. And again, it was a great surprise for pretty well everyone that on the island of Flores, which is beyond where we thought ancient humans ever got because they didn't have boats. So this is an island, quite a remote island beyond Bali, sort of heading towards Australia. So this island, we know that there were claims that humans were there from stone tools, but these were disputed. Early humans were there. And then these fossils were found and published in 2004 of what seemed to be a dwarf species of human. So really a small stature, just over a metre tall. There's a reasonably preserved skeleton with a cranium. Small brain about the size of a chimpanzee. Very human teeth, but no sign of a chin. A brow ridge over the eyes, and a skeleton that had a mixture of, features that we expect in humans, so walking upright, but in the feet, in the hands, in details, seemed much more primitive. It was really much more like, in some ways, fossils that are 2 million years old than ones that are, well, we now know 60,000 years old, some of these fossils. So, as modern humans were coming out of Africa, this strange species was still surviving, probably having evolved there on Flores for over 1 million years, because Flores has got stone tools over 1 million years old, and there are even fragmentary fossils about 700,000 years old, which look like the ones that we find later on of Homo floresiensis. So a long, deep lineage evolving separately in isolation for a long period of time, and then going extinct. And that's one of the questions, of course, is why are these other human species going extinct around this time?
But that's so interesting that you actually mentioned there around tools, because it might seem obvious to you, but to many people, myself included, you might get the mistaken impression that Homo sapiens are the ones with tools and stone tools and the like, but there are many other types of hominins that were able to use tools long before Homo sapiens.
Yeah, that's right. Yes, I mean, we are a tool-using human and tool-making human, but this is something that's been around for over 2 million years. So we know that something was making stone tools in Africa more than 2.5 million years ago, and this is even earlier than some of the earliest Homo fossils. So it's likely that this earlier stage of humans, the Australopithecine, the southern ape phase in Africa, some of those creatures, which in many ways were ape-like in terms of their brain size, they were probably already using and making tools. Fairly basic, of course, at that stage, and things like wood, that would have been used, but of course most of the evidence, pretty well all the evidence, has disappeared. So what survives are stone tools, but they're certainly there more than 2 million years ago in Africa. We may find them around butchered remains, suggesting that these stone tools have been used to butcher animal carcasses, to cut off the meat, break open bones to get the marrow. So that's something that's there over 2 million years ago, and so by the time we get to the Neanderthals and us, we're talking about very sophisticated tool makers and tool users. So much more complex technology, specialised tools for cutting meat, for cutting wood, for breaking open bones, for processing skins, things like that. We get quite specialised tools. Yeah.
Chris, this is all so interesting. I could ask questions for hours about this, literally, but we're going to have to start wrapping up now. I mean, a last kind of question and statement. It's absolutely extraordinary from what you've been saying about the progress, the advancements that have been made over the last 30, 40 years, a really exciting era for looking at the origins of Homo sapiens and other hominins. But from what you've also been saying, these new discoveries, new DNA, research, even to this day, it's really exciting for the future, isn't it? When we're starting to learn even more, we're going to find even more discoveries, shedding new light on this very distant but important part of our past.
Yes, absolutely. I mean, we've had important discoveries and those are going to continue. And as I mentioned, there are these empty spaces on the map. So, you know, large parts of Africa with no human fossils for this time period. The Indian subcontinent with only one significant human fossil from that whole area. So many parts of the world still to yield important evidence, DNA data to come. I mentioned this method of proteomics, where we can look at fossil proteins which have a longer term survival than DNA, and that method is going to be increasingly applied to these fossils, and that will help us also relate these fossils to each other. Better dating techniques, of course. So all of this, I think, we can look forward to a very rich story still to come. More complexity, but also probably sorting out some of these questions that I've raised that are still doubtful. So where did Homo floresiensis evolve from? We don't know that. Where was the common ancestor of us and Neanderthals living? We don't know that now. We may get discoveries, I hope we'll get discoveries that will help us home in on those. And also, what did the Denisovans look like? We haven't talked much about that, but the Denisovans, of course, are known from fragmentary fossils. There is a jawbone from China that's thought to be Denisovan, but somewhere in China, I'm sure there are some much more complete fossils that are Denisovans, and so that's something that we can look forward to for the future.
Well, China seems to be this key place, doesn't it? You mentioned just before we started recording Dragon Man, this new discovery, which also seems to seize the world in its importance.
Yes, it's it's a beautifully preserved fossil, over 150,000 years old, and it seems to represent, for me, a distinct species living in China. I'm calling it Homo daliensis. And of course people are saying, well, that's a Denisovan. Well, that's for me, that's not yet resolved. It may well be a Denisovan, but we have to demonstrate that scientifically.
Well, Chris, this has been absolutely awesome, and it just goes to me to say thank you so much for taking the time to talk to History Hit today.
I've enjoyed it very much. Thank you.
Welcome to the History Hit YouTube channel. Hope you enjoyed that video.
And if you'd like to see more videos where we attempt to try and bring history to life, please don't forget to subscribe and hit that notification bell.
Cheers guys, see you soon.